In this video, I'm going to cover the right triangle trig ratios. And there's an acronym here that will help us to remember these, which is SOHCAH-TOA. S stands for sine, C in the CA stands for cosine, and T stands for tangent. And basically these mean sine of an angle theta equals the ratio of the opposite side over the hypotenuse. Cosine of an angle theta equals the ratio of the adjacent side over the hypotenuse, and tangent angle theta equals the ratio of the opposite side over the adjacent side. Given right triangle ABC with sides measuring 8, 15, and 17, we can use SOHCAH-TOA to set up our trig ratios. So talking about angle A here, which I have marked, and knowing that sine is opposite over hypotenuse, hypotenuse is always the side opposite the right angle. So when we go to set up our trig ratio for sine of angle A, we're looking for the opposite side of angle A divided by the hypotenuse. So our 17 for the hypotenuse goes in the denominator, and since A is this angle at the top, we look opposite of it to the side 15 to get our numerator. So sine of angle A equals 15 over 17. For cosine, we're looking for the adjacent side over the hypotenuse. So our hypotenuse will be the same value, since we're still talking about angle A and we're still looking at this right triangle with a hypotenuse of 17. The adjacent side, meaning a side touching angle A, we never use the hypotenuse for the adjacent side, so that means our adjacent has to be 8. So cosine of angle A is 8 over 17. To solve for the tangent of angle A, we use opposite over adjacent, and we know the opposite side of A is 15, and the adjacent side is 8. So these are our three main trig ratios that we can set up for this triangle. We can also solve for the three reciprocal functions. Since cosecant is the reciprocal of sine, then cosecant A is 17 over 15. We just flip that fraction over. Similarly, secant is the reciprocal of cosine, so its value would be 17 over 8. And cotangent is the reciprocal of tangent, so its reciprocal here would be 8 over 15. It's important to note that these three trig ratios vary depending upon what angle we're talking about. So let's set up our trig ratios for angle B. Now the hypotenuse is still going to be 17 because that's what's across from the right angle. However, when we're talking about angle B, the opposite of angle B is now going to be the value 8. So sine of angle B will be 8 divided by 17. Cosine of angle B, we need the adjacent side, which is 15, over the hypotenuse, which is 17. And then the tangent of angle B is the opposite of B, which is 8, over its adjacent, meaning the side that is along the side of angle B, which is 15. So these are the three main trig ratios for angle B. Once again, we can do the reciprocal functions of these by just flipping the fraction upside down. So cosecant of angle B will be 17 over 8. Secant of angle B is 17 over 15, and cotangent of angle B is 15 over 8. Let's put SOHCAH-TOA to use in solving for missing sides of a right triangle. In our first example here, we have angle A is 50 degrees And we see that we have a hypotenuse because it's across from the 90-degree angle and it measures 15. And according to this angle A, this x here is an opposite. It's the opposite side. Therefore, we will use sine of angle A to set up our trig ratio. So we will say sine of 50 degrees equals the opposite side of x divided by the hypotenuse of 15. Now, we could put a 1 under sine 50 to make this into a proportion, and then we can cross multiply and set our cross multiples equal. So x is going to equal 15 times sine of 50 degrees. Now, if you put that into a calculator, you should come up with approximately 11.5 when we round to the nearest tenths. This second example, we have an adjacent side of y and a hypotenuse of 12. So therefore, we're going to use the cosine function. So cosine of angle 40 equals the adjacent side y over 12. And again, we could put a 1 under here and cross multiply and set our cross multiples equal to one another. So 1 times y is y, and 12 times cosine 40 degrees is what that equals. If you type that into a calculator, we should come up with approximately 9.2. So in other words, 9.2 is the length of this side. Lastly, let's look at a tangent example. Across or opposite of our angle 68 is an x, and adjacent to the angle 68 is 14. Since I'm dealing with opposite and adjacent, I choose the tangent function. So tangent of 68 degrees equals the opposite value of x divided by 14. Again, we can cross multiply. We get x equals 14 times tangent 68 degrees, which is approximately equal to 34.7 when we round to nearest tenths. Let's look at solving some more using a different position of the angle. In the triangle to the left, we are given angle B is 35 degrees. We are trying to solve for x, which is opposite of 35 degrees, and we are given this side of 10, which is opposite of the right triangle. So which trig function should we use? Cosine, sine, or tangent? Feel free to pause the video and work this problem out and solve for x. So if you said the sine function, you are correct. We should set up sine of 35 degrees equals the opposite side of that angle divided by the hypotenuse. Now we can cross multiply here and get x alone, and x equals 10 times sine of 35 degrees. And when you put that into a calculator, you should come up with 5.7 if you round to nearest tenths. For this second triangle, we are given this 16 value down here, and we're trying to solve for y. Which trig function should we use? Cosine, sine, or tangent? If you said cosine, you are correct. Cosine of 40 degrees equals the adjacent side of 16 divided by y. Now there's a trick you can use here. Rather than cross multiplying and then having to divide both sides by cosine 40, we are able to switch our cross multiples And if we do that, we will get directly to the exact answer of y equals 16 divided by cosine 40 degrees. Now, if they want the rounded answer, 16 divided by cosine 40 degrees is going to equal approximately 20.9. For the third problem, we are going to need to use tangent. Tangent of 25 degrees will help us to solve for this x here because we are given the opposite side of 8 and tangent is opposite over adjacent and x is the adjacent side. And once again, we can use this trick. You could cross multiply, but then you would get x times tangent 25 degrees equals 8, and you would have to divide both sides by tangent 25 in order to get x alone. So the quick way to do the problem is just to reverse these two, and you would get x equals 8 divided by tangent 25 degrees, all in the first step. When you put that into a calculator, you should come up with 17.2 when we round to nearest tenths. I hope this helps in solving for the trig ratios. If this video was helpful to you, please like, subscribe, or comment. Also, feel free to let me know if there are any other topics you would like me to make a video for.